Good morning, everyone. Thanks for having me here, Mike. So my name is Kamal Ben, and I am the Aeronautical Research Coordinator for WISA. And I'll be talking today about the flight simulator that we have at the Faculty of Environment. So I'll be going through the agenda of today's presentation. So I'll be first introducing WISA and why we work at WISA and what we do at WISA. And I'll be talking about general aspects of flight simulation. And then I'll present the ALSIM 250, which is the flight simulator that we just acquired last year. And then I'll present a couple of projects that we're working on right now. And then I'll be happy to answer any questions we have. So WISA is the newly founded institute. It was founded last year, and the founder is an associate professor in the aviation program, which is Dr. Susan Kearns. And the mission of WISA was to bring together industries and government organization with academic to find solutions to sustainability aspects in the aeronautics industry. So like beside the usual challenges we face, like whether they're social, like economic or environmental, we saw how the COVID impacted the air transport sector. And that's why here the mission of WISA is to find or to help in promoting these sustainable changes, and also to create a new generation of professionals to engage and to promote these sustainable changes. So now, talking about flight simulators, to put you in the context, I put this definition. So a flight simulator reproduces artificially a flight of an aircraft in a specific environment under controlled conditions. So I have highlighted a couple of keywords, and I'm going to focus in the two last keywords, which are environment and controlled conditions. So when you fly an aircraft, I mean, usually you just fly. I mean, when you do your pilot training in any flight school, so you just fly the aircraft that is available, but not necessarily in the conditions you want. I mean, we fly in safe, like for example, weather, but you want to train for types of weathers, and to have this flexibility in things, it's good to do that in flight simulator because you cannot do this in real life. So, and the other thing is, like, any flight simulator has to be certified by any like a regulation organization for being used in pilot training. So we categorize flight simulators using three major parameters. So the first one is the level of sophistications. So for example, because we are artificially reproducing the flight, so that means we're creating a model that can generate the same feeling of flying. Okay, so like it can be aerodynamic model, like acoustic model, anything like that. So the motion as well. So it produces a certain level of realism in your flight. And lastly, the regulation under which your flight simulator is being operated. So in general, we have two main categories of flight simulators. Like we have what we call the FTDs, which are flight training devices, and we have 7 types. And also we have the other category is the levels of flight simulators. We have level from A to D, and D is the most advanced or the most sophisticated flight simulator. And this is, I mean, it's only for airlines. I mean, we're talking about like $15–20 million flight simulator. So it has like full motion and a lot of realism stuff. So here I'm like presenting like 3 types or 3 figures which reproduce like a flight simulation environment, and the 3 of them are flight simulators. So the first one on the left-hand side is just a software that you can have in your computer, and you can fly any type of aircraft anywhere in the world and any weather conditions. And you can just have like a small joystick with this certain throttle to simulate your flight. But this does not necessarily reproduce what you want to have in your pilot training. So if you want to have more fidelity things, you can add some other equipment, like some interfaces to reproduce your environment. And lastly, I mean, the one on the right-hand side, this is what we call, I mean, the level D I was talking about is like a huge simulator where you can have like a full motional cockpit, and that's what we call the FFS, or full flight simulator. So now I'll be presenting the ALSIM 250. So the ALSIM 250, actually, it's like this flight simulator, like it's when you look at it from the outside, it's a small box, like it's it doesn't look like it's a flight simulator. But when you look into the inside, So we have here like it's composed in two compartments. So the front compartment, which is the cockpit, or what we call the simulated area. So that's what we're simulating. Like we're simulating the flight, and you have like a cockpit environment, like with all the flight controls, the flight instruments, the pedestal where you control your throttle and everything, and you have the outside view that reproduces the environment. And then on the back end, you have another compartment, and that's where generally the instructor who is doing the instruction for the pilot, student pilot. And this compartment is what generally we call the NSA, or the non-simulated area. So the instructor is the one who is generating or the controlled conditions I was presenting above. So the way the flight simulator is designed, I mean, it has like certain number of computers, and it starts actually from the instructor station, and from that where the starting point that connects directly to 4 other computers that I'm presenting here. They are under a bench, and we have 3 of them. They control the visual system. So the front visual system is the one who controls the other, actually. So like if we don't start the front computer, like all the projects cannot start. And then like all the other computers as well, they connect to the other like cockpit instruments, like the flight deck, like the pedestal, and also the control loading and the force feedback module. So speaking about the visual system, so when you sit inside the cockpit and you have to see like your external environment, and this is reproduced like using 3 projectors that they are mounted on top of the roof of the simulator. It's like we have 3 of them. Like the front one projects to the front of the simulator to give like a front view, and then you have left-hand side projectors which project to the left-hand side. So when you sit inside the cockpit, so you can have a 3D view, like in certain field of view, like which is about 230 degrees from the left to the right. And then also vertically, we have a certain field of view from the pilot seat. The advantage of having a flight simulator is like you can fly different type of aircrafts each in just a simple click. So you can decide, for example, if you're on a train today in a single aircraft. I mean, first, I mean, the type of aircraft that we fly in general aviation for flight training. So we have the what you call the single engine aircraft or multi-engine aircraft. So single engine because it has 1 engine, like 1 propeller. Multi-engine, it has 2 engines or 2 propellers. So in general aviation, like when you train, for example, for your private pilot license or commercial pilot license, like you train in a single engine, and then when you do your rating in multi-engine, you fly the multi-engine aircraft. So we can fly any type of these aircraft inside the simulator just by changing the menu of the aircraft, and then the simulator will automatically load the cockpit of each aircraft. So the cockpit can be designed or loaded in 2 versions. Like I mean, we have what we call the old version of aircraft. Like for example, for the Cessna 172, like you can have analog flight instruments. So which means like when you're sitting, like you can see like your airspeed indicator, your attitude indicator, your altimeter. I mean, all these are like analog instruments. In newer versions of aircraft, we have what we call glass cockpit. I mean, glass cockpit, it just means like it's a screen, which is more viewable, and it has like more, sometimes that's more information. For example, like you can have like wind information being displayed and everything. So the pedestal, so since this is like a simulator and we fly different types of aircraft, it is composed of, like audio communication panel, like you have your GPS, you can have your transponder. And since you're flying, like you're gaining altitude, and when you gain altitude, you have to control the air to fuel ratio. That's why you have your throttle and your mixture here. So when we fly, like for example, a single engine aircraft, we just need 1 single throttle with 1 mixture. But when you fly a twin engine aircraft, we need 2 throttles. So what happens in that case, we just have to replace this pedestal module here with the multi-engine one. So this is like fully integrable and modular. And then we have the fuel tanks at the back of the pedestal with the rudder, the trim rudders. From like when I was speaking earlier, inside the cockpit, that's what you have, but behind the cockpit and in the instructor station. So that's where we create the controlled conditions of flight. So the instructor can choose. I mean, we have, it's simply a computer actually. So it's just like a computer with the software that controls the environment of flying. So we can change the position. So we have a database of airports. We can fly anywhere in the world. Like you can choose an airport in Canada, in the States, in Europe, in Australia. So we have database of airports that we can train, and you can go and fly into these airports. We can also change the weather conditions. Like we can have rain, snow, wind conditions, crosswind, like clouds, like different layers of clouds. I mean, when you fly, like in general, like non-visual environment, or like at night, for example. So you can create all these environments to provide a full immersive environment to train the pilot. And the other aspect of using this is to having, for example, failures. So obviously you want to try this in simulator, not in real life. So you can have an engine failure, flight controls failures, or instrument failures as well. And we have different other options and presets that we can play in the simulator. Like you can add runway lights, you can change the aircraft, as I was mentioning earlier. You can change the type of aircraft you want to try and everything. So the beauty of having this flight simulator is like, that's what we use in research, is having an external computer which is connected to the flight simulator, and from which we can actually do some engineering stuff. So like, beside the fact that we use a simulator in flight training, this one we use it for research, and for research we have to understand what is the pilot really doing. I mean, you can sometimes like understand by just seeing the flight instruments, but like if you want to have like a full time history of what the pilot action is going, like you have to like we use the engineering pack. It's a computer in the back of the simulator that tracks like everything that the pilot is doing. So we have a list of variables that we worked with ALSIM, and ALSIM, like they help us like generating an interface, and we can track anything that's going on inside the cockpit. So we can know, for example, in a fraction of a second, like what the pilot is doing, how much pressure is he doing in his yoke, like at what time he engaged, for example, this command. Did he use the flaps at that moment? When did he start turning, or when did he start descending? So all this information, they can help us understand like the pilot behavior, and they can also help us in the future, like provide like a general understanding of the pilot competency and knowledge. So lastly, couple of projects that we're working on. So here I'm showing a video of one of the projects we are working on. So it's a project of a PhD student who is Naila Ayala. She's a PhD candidate at the Faculty of Health and Kinesiology. So she's supervised by Professor Eva Nechwitz-Widow. So the red dot that you see in the cockpit moving, it's actually the eyes of the pilot. So here we're tracking what the pilot is doing with his eyes. I mean, when like you fly an aircraft, I mean, there are a lot of things that you need to manage. I mean, besides looking at your flight instruments, I mean, there's a certain pattern that we train the pilot to look at. So like you scan the instrument, you interpretate what's going on, and you take action. So a simple way to explain this, like when you are driving in a highway, like you just see how fast you're going and how much fuel you still have. But when you're flying, I mean, you have to see how fast you're going, how high you are, or how fast are you climbing or descending, and also where are you going? I mean, which heading direction are you taking? You cannot just change direction as you want. I mean, you know, there are a lot of aircraft flying nearby you, especially at low altitude and close to the airport. So you have to be careful to not get into trouble. So here, like with this project, like it's simple glasses that we put on the pilot. So we have a couple of candidates, and they trained, or they try this experiment. The other project that we are working on is a similar one, which is a project of Alison Lynch. She is a master's student and supervised by Professor Elizabeth Irving from the vision faculty. So instead of like tracking the eyes of the pilot, we are studying how the vision decrease, or like when we decrease the vision of the pilot, is he still able to fly the aircraft? So, you know, we have like standards for flying, like to have your pilot certificate, you need to be medically fit and you have to have a certain vision. And that's why we're working towards this project. So there are a lot of information that we can share. So that's it. I hope it was not that quick. So I'll be happy to take any questions.
Okay, thank you, Kamal. Yeah, if you have any questions, just type it in the chat or like just shout it out, and like I'm sure Kamal can answer your question. Okay, I have a question, like Kamal. So how many types of aircrafts can you simulate? Like you said, like about those 3 types, like a single engine and multi-engine. Like, can you like do also like big Boeing 747 or something like that, or is it just like those smaller ones?
No, this is for general aviation simulation. So we only generate general aircraft type of aircraft, like single engine aircraft and multi-engine. And the single engine, we have 2 types. Let me go back to the types here. So we have like what you call like normal single engines, like single engine piston. So it has like a fixed gear, or we have like a complex configuration, which means like the gear of the aircraft or the wheels can be retractable. So this type of single engine plus the multi-engine one.
Okay. And Jennifer had a question in the chat here, like when tracking the eye movements, do the user wear contacts, or how is it done?
No, actually, they use glasses with the software. I mean, we have a software provided by a company, and that software tracks the eyes movement.
Oh, okay. And Elizabeth put something in the chat that is generate a tremendous amount of data. Are there specific methods for the analysis of the multitude of outputs?
Yeah, actually, we have a huge amount of data. It's really huge. I mean, we have about, in the sim, like we can record up to 3,000 variables at the same time. Okay,
wow.
But for our study, we're focusing now, like exporting just 1,000, and within this 1,000 variables, we're focusing on a couple of them. I mean, we worked with Naila and ALSIM to define what we need for the type of project we're working on. And for the analysis thing, so there are certain parameters that we will focus on, like the control feedback of the yoke, the pitch attitude. You can divide your time history signal on different phases of your flight. Like you can know when the pilot turned from base to final, or when did he start descending, or anything like that.
Okay. Another question, how many pilots are you hoping to have for your study?
Well, for the project of Nile, I think we've had about 20. And for ALSIM, I think it's about the same.
Quite a few. I have another question too. Like you mentioned the category and the level of the flight simulators, like that 1 to 7 and A to D. So which one is the ones we have here?
Oh, this is an FTD. So this is and this is not certified. So to mention, so a flight simulator is used to train pilots. So when you for example, you try to claim that your license, you have to log certain hours, and to log your hours, you have to log them in a certified simulator by the authority. So the simulator that we are using here is not yet certified by Transport Canada. So we do not use it for flight training for now, so only for research.
But is that the goal in the long run?
Say again?
To have it certified, is that the goal in the long run?
Yeah, we are working on it. I mean, we start working on it, but it's a certain process that we need to work with ALSIM and also with Transport Canada.
Are you working with a school for students just learning, or are these certified pilots?
These are like general aviation pilots. So some pilots, like they have, for example, just private pilot licenses, or sometimes private, commercial, and multi-engine. And the range of hours, if you want to convert this in the range of hours, like it can range from 20 hours to up to 200 hours each.
And how long does it take, like, to like switch from like to set up like a certain environment for like a certain aircraft?
Oh,
like
couple
you just
seconds.
press it. Okay.
Yeah, couple seconds. Yeah. So like it's a menu that we have in the instructor station. Like you can choose the type of aircraft, the type of weather, and yeah. And it takes like a couple seconds to load for ALSIM.
And in terms of like simulating like turbulences, like does it actually rattle or whatever, or is that like not quite that level of simulator?
No, yeah, we have. I mean, this simulator is kind of like it has good models. Like when you put wind conditions, you can feel the wind conditions.
Okay.
Like we have some pilots who, for example, like you put a crosswind and you can see that when they turn, like you can see the wind pushing them, so they have to readjust their approach to land.
Thanks again, Kamal, for this presentation. Like we had a little trouble at the takeoff, but otherwise it was smooth sailing, I think, and very interesting. And I'm looking forward to like at one point like get up there and like check that out myself and see what it's like.
Yeah, thank you, Mike. Thanks for having me here.
Thanks very much.
Thank you.